Hello class, let's take a look at example 2. And example 2 deals with, well, in this scenario, actual voters. And what we technically have here is a binomial problem, and the main idea is that this is binomial because they're either going to vote or not. So as you declare your variables, make sure that, well, in this scenario, we're talking about x being, total number of voters. Now, the main statement that they're asking is that we're evaluating the probability that at least 7 of 1 actually voted. So we have a binomial problem with the following parameters. The 1002 represents the total number of people or trials, and the probability of success is 0.61. So to evaluate 7 of 1, you're basically doing the following. So this is the probability of x is greater than or equal to 7 of 1. Now, they're not asking for the normal approximation. So as you evaluate the actual binomial, you have to change it to the actual complement. Now, in your calculator, you're going to be evaluating the following. Now, remember that x greater than or equal to 7 of 1 in terms of the complement is 1 minus the probability of x less than or equal to 700 because the random variable happens to be discrete. So calculator wise, we're going to be evaluating 1 minus, and to evaluate less than or equal, we're going to have to actually use the binomial code, but it'll be the binomial CDF. So in this case, 1000, whoops, let me go back. 1002 for the values of n. The probability of success is 0.61. And as we're finding the complement, well, the complement of greater than or equal to 701 is 1 minus the probability of x is less than or equal to 700. So in this case, let me punch it in. So 700 for the last portion of the parameter. And please run the code and see, oh, there's an error. It's supposed to be normal CDF. So ignore that. And then this is 1 minus the actual code. And this is the CDF. So 1002 and 0.61 with the actual 700. Okay, there we go. Run it again and then verify that you're matching. In this case, the probability that greater than or equal to 701 happens to be translated to 1 minus the probability of x is less than or equal to 700, which in this case it ends up being almost 0. Now, in this scenario, the problem happens to be a binomial, and they're not asking for us to do the normal approximation. So you only do the normal approximation if they're asking us to evaluate. Otherwise, we're going to be carrying error, and if they're not asking us to do the normal approximation, in this case, the CDF will give us a better approximation to the binomial problem.